Okay, now I want to show you how to solve this problem. This diagram given, and these are the instructions and questions that we are asked to answer. Okay, let's look at the instruction or the question. The question says that two cylindrical pipes of unequal diameters intersect as shown in the diagram below. Using the given data, draw from question A, the given view, question B, a plan, question C, the curve of interpenetration of the two pipes, and question D, the surface development of the smaller pipe using AA as seam. Okay, this question is a WAEC question. So, and it comes under a topic, surface interpenetration, and is also a combination of surface development, interpenetration or intersection of surfaces and surface development. Okay, so we have two things that we are going to do here in order to solve this problem. So it has been solved by somebody here, but I want to show you how you can solve this particular question. So let's look at the features of the question, the dimensions given. So we have the vertical cylinder. This is a vertical cylinder. So the diameter of the vertical cylinder is 40 mm. So this is a symbol for diameter. So the diameter of the vertical cylinder is 40 mm, and the height of the cylinder is 90 mm. Okay, now we have this cylinder that penetrates, that enters into this cylinder. So we have it, this is the cylinder that enters into this cylinder or penetrates it. So the diameter of that cylinder is 36, and we have the length from the end here down to this point is 70 mm, and this line is inclined at an angle 45. So the angle is put here, so it means that this line, since this line is parallel to this line and this one is also parallel to this line, it means they are all at angle 45 degree to the horizontal line. And then this point where we are going to take this center line from is 20 mm away from the bottom of the vertical cylinder. Okay, so the solution goes as follows. The first thing that we are going to do here is to draw a vertical center line. That's the first thing we are going to draw. So vertical center line. So draw a vertical center line. So I'm doing it here. Okay, so the next thing is I will draw horizontal center line. Okay, so I've drawn the horizontal and the vertical center line. So the next thing I'm going to do is that I'm going to draw a circle. So the plan of this vertical cylinder is a circle, is a cylinder. So if you look at a cylinder, its upper face is in circular form. So when you are looking at it down from here, so you see that circle. Okay, so we are going to draw a circle of radius 20 mm because the diameter of this vertical cylinder is 40 mm. So we draw a circle of radius 20 mm. So we take 20 mm from our ruler. Okay, so 20 mm from the ruler as the radius of the vertical cylinder. Okay, so this is 20. So put it at this point and draw a circle. So the circle goes like this. Okay, so this is the circle. All right, so the next thing I'm going to do is that, so move up this a little bit, just go up a little and draw horizontal line like this. Draw horizontal line, and then at this end of the circle, produce a vertical line. Produce a vertical line up. When you touch that horizontal line, stop it there, and then you come to this end too. Draw a vertical line. So when you touch the horizontal line, you stop it. Okay, so I can take it up. It's a cylinder, so let it go up, and then this also, let it go up. It's a cylinder, let it go up. Okay, so now measure 90 mm. So measure 90 mm on this line. So starting from here, from this place, starting from here, measure 90 mm up. So this is 90. So this is 90 mm here. So that's the height of the vertical cylinder. So I still need to produce this up a bit. Okay. And so this goes up a bit. Then we now move up and draw the upper part of the cylinder. Here is it. Okay, so this is the vertical cylinder. So the next thing I'm going to do is that I want to draw the penetrating cylinder. The penetrating cylinder. So as I've said before, that this line, the central line or the penetrating cylinder, is 20 mm away from the bottom of the vertical cylinder. 20 mm away from the bottom of the vertical cylinder. So I will measure 20 mm. I measure 20 mm from here. So 20 mm goes up. So this is 20. So this is 20 mm here. Okay, so the next thing I'm going to do is that with this 20 mm, so this central axis, so the line in the middle of the penetrating cylinder is inclined at angle 45 degrees to the horizontal line drawn at this 20. So if I draw horizontal line at this point, which is 20 mm from the bottom of the vertical cylinder, then I will take my 45 degrees set square, put it at this point, and I will draw the center line for the penetrating cylinder. That's it. Center line for the penetrating cylinder. Then I'm going to measure 70 mm as we have here, that from here to here is 70 mm. From here to here is 70 mm. So I will measure 70 mm on this line. I measure 70 mm on this line. So starting from here. So this is 70 mm. Okay, so with this 70 mm, so I will take my 45 degree. I'm going to draw a line at this point that will be at an angle 90 degree with this line. That will be at an angle 90 at right angle to this line. To do that, as we have used 45 degree to draw this line, you also use 45 degree side of your set square to draw it, as I'm doing it here now. Okay, so by the time I draw this from here to here, so the angle here is 90. Angle between this line and this line here is 90 degree. Okay, so the next thing I'm going to do now is that I'm going to draw a semicircle, and that semicircle is for this cylinder, for the penetrating cylinder. So we have the diameter is 36 mm. So 36 by 2, that will give us 18 mm. I will take 18 mm on my ruler. 18 mm on my ruler. So take 18 mm. on the ruler. So this is 18 mm. I will put it at this point here, and I will draw a semicircle. I will draw a semicircle. Okay, draw a semicircle here. Okay, this is a semicircle. So I need to extend this line a bit. I need to extend this line. So it goes like this. Okay, so the next thing I'm going to do is that I'm going to divide this semicircle into 6 equal parts. So this is how it goes. So put your compass at this point here. Put your compass at this point here. So let me call this point. Let me call this point. Let me call it point. Let it be 0, and let this be 6. Okay. So I put my compass at this point. I will make an arc here. Okay, and then I will put at this point here. Put at this point. I make an arc here, and then I make an arc here. So then I will put it at this point 0 here, and then I will make an arc here. Okay, so that's it. So I will number this. So this is 1, this is 2, so this is 3, this is 4, and this is 5. Okay, so that's the numbering. So the next thing I'm going to do now is that I'm going to use my 45-degree set square to draw a line from each of these points. So if I draw a line from 0, when it touches this cylinder here, I will stop it based on what we have here, this line. So when it touches the surface of the cylinder, vertical cylinder, I will stop it. Then I will also draw a line from 1 here, a line from 1. So this line that I'm to draw from 1 will go straight. It will go straight into the cylinder, to enter into the cylinder. Then the next from 2. Go straight into the cylinder. Okay, so next 4. So 3 is already drawn, so it goes straight into the cylinder. And then I move to 5. I move to point 5 on the semicircle. So this one will also go straight into the cylinder. It goes like this. Then 6. So when you get to the surface of the cylinder, it stops there. As we have it here, this is it. As we have it here, so this is it. So it stops on the surface of the cylinder. So the next thing I'm going to do is that this is the plan for the vertical cylinder. So we need the plan of the horizontal cylinder. So we don't know it yet. So how do we draw the plan for the penetrating cylinder, not horizontal, for the penetrating cylinder? This cylinder is inclined. So how do we draw the plan for this cylinder? So I'm going to extend this center line a little bit. Okay. So now from each of this point here, from this point on this line, this point, and this one, you draw vertical lines down. Okay, so it goes like this. So set your set square at 0 and support it with your t-square. So draw a vertical line down. Then you move to 1. Draw a vertical line. Then move to 2. Draw a vertical line. Then move to 3. Draw a vertical line. Then to 4. Draw a vertical line. Then to 5. draw a vertical line, then move to 6, draw a vertical line. So this is it. Okay, so all right, so the next thing that we are going to do is that I'm going to draw a semicircle as we did here. I'm going to draw a semicircle. I'm going to draw a semicircle as we did for so this line is not okay. So I'm going to draw a semicircle. I want it outside. I don't want it to be part of this. So I want it to be outside. So I'll just move away from this a little bit. Just move away from here and draw a vertical line. Draw a vertical line. Then I need to extend this a bit. Okay, so the next thing is with this, this is 18 mm, which I use to construct this semicircle for the penetrating cylinder. So I will still make use of it here. So I put it at this point, and draw a semicircle again. So the semicircle goes like this. So I will divide this semicircle into 6 equal parts as we did up there. So okay, so after drawing this semicircle and dividing it into 6 equal parts, so I've done that and I've labeled this semicircle at okay. So we are going to draw a line from each of these points, on the semicircle. So we draw a line. So I will draw a line. So when it touches this circle, I will stop it there. So that is from 0. Then from 1, so draw a line. When it touches the circle, stop it there. Then from 2, so draw a line. When it touches the semicircle, stop it there. So 3 is already done. Then from 4, draw a straight line. When it touches the circle, stop it there. Then from 5, draw a line. So when it touches the circle, stop it there. Then from 6, draw a line. When it touches the circle, stop it there. Okay. Okay, so this is it. So the next thing that I'm going to do is that when you are looking at this penetrating cylinder, when you are looking at it from the top, you are going to see a circle. This is it. You are going to see a circle, but because it is inclined, it will not look like a circle. When you draw its plan, it will not look like a circle. It will look like an ellipse when in its plan. So that's what I want to bring out now. Now, following this, so following what we have here, so if I follow this line, this is the center line, which is line 3. So if I put 3 at this point here, and I also put 3 at this point, okay, then so looking at this line here, this line that comes here, so I label this 3 prime. So this is 3 prime, and this is also 3 prime. Okay, now, so looking at this one, okay, so what we just need to do is that we need to note this point here, this point and this point here, and then this point 3 prime here, and this point 3 prime here. Okay, so just look at the way I'm going to do it. Okay, so here we have what? Let's look at line 1 here. Okay, sorry, this should be 0. This should be 0. If I follow what I have up there, this is 0 and this is 6. So coming down from here, this is 0, and coming down from here, this is 6. Yeah, it is 6. Okay, so this is 6 and this is 0. All right, so the next one I'm going to look at is line 1 from here. Line 1 from the up here. So if I follow line 1, coming down like this, coming down here. So line 1 here. This is line 1 here and line 1 here. So if I follow them, they meet at this point. This horizontal line 1 and the vertical line 1, they meet at this point. They intersect at this point. Intersect at this point. And if you look at point 5 here and point 1 here, they are along the same line. They are along the same line. So this point here, where I have 5 prime here, I can also call it line 1. I can also call it line 1. Okay, so the next one is line 2. If I follow line 2 from here down, if I follow it down here, so line 4 and line 1, point 4 here and point 2 here, they are along the same line. So I can call this point, Okay, what I will just say is that to make our work faster, so after this point here, just move in a little bit, go inside a little bit, just move inside. So after this point, just go in like this. So you have this point. So put a dot there, then move in again, move up and go inward a bit. So we have this point here. Okay, but I do the same thing here. So I have this point here, and then I have this point here. Okay, so here, so if I come here, this point and this point here, they are along the same line after these 3. So we have this point, then I have this point here. Then coming down here after this point, so I have this point here. I have this point. And then I also have this point. So I'm going to join this together with the use of my French curve, So here is it. So set the French curve. So set it very well. Okay, so I can join this point together. All right, so let's join together. Then so join the point together with the use of the French curve. So I can join this together. Okay. I'll come and join this together. So this can go with it. And this can also go with it. So this is the plan for the penetrating cylinder. This is the plan for the penetrating cylinder. So I need to make this edge thick, and then I will also take this edge here. Okay, so this is it. So this is the plan for the penetrating cylinder. Why this is the plan for the vertical cylinder. So the next thing I'm going to do is that at a point where these lines drawn from the plan of the penetrating cylinder touch the circle, I'm going to draw vertical lines into the vertical cylinder, this point. So this one is already drawn as a vertical line. So I will also draw a line from here, from this point, and also from this point. So they will go up into the vertical cylinder. So this is it. Okay. So this goes up. And then it also goes up. And this goes up. This. Okay. So looking at what we have here, okay, so we are going to produce a curve of intersection, and it goes like this. So from this point on the cylinder, on the vertical cylinder, where this line touch on the cylinder, that's first point up there, and this line, it touch this cylinder, the vertical cylinder at this point. So we have it, they intersect here, okay. So the next one is that you go inward a bit. So you go inward a little bit. Okay, so let me take it from here. So after this point, I have this point here. Then I move down. So I have this point here. Then I have this point. Then I have this point here. And then we have this. Okay, so I'm going to join this point together with the use of my French curve. So it goes like this. So using my French curve, so it goes like this. Okay. Okay, so this is it. So we have drawn the curve of intersection. So I need to make it more feasible. So I'll take this edge. Okay. So, and then this circle, I will also make it thick. Okay, so we have answered question A, the given view, and question B, the plan. Question C, the curve of interpenetration of the two pipes have already been done here. So we now go to the last question, which is the surface development of smaller pipe using AA as a seam. So though AA is not shown here, but I know where it is. So this is point A, and this is also point A. So it's a seam. So a seam is a line on a cylindrical object that shows where the edges of the rectangle is joined together. So what I mean by seam is this. If I fold this paper like this, so they join together at this point. So this point is the seam. This point where I joined this rectangle together is known as the seam. So it is joined together at this point. So we want to produce the curve of intersection. I'm going to separate it. I'm going to separate the curve of I'm going to separate the surface development from the object itself, unlike how it is done here. So I can separate it, I can put it somewhere else. I can put it somewhere else. So it goes like this. It goes like this. So I'm going to draw a line. So I will draw horizontal line from here. So draw horizontal line from here. Okay, so that's the horizontal line, and I will also draw a vertical line here. Okay, so if you remember, so this cylinder is 70 mm long, 70 mm long. This line is 70 mm long. So I'm going to use this line 70 mm. So that I will take that 70. So if I take 70 mm here. So taking 70 mm here. Okay. If I take 70 mm here. So this is 70 mm. And I will draw the horizontal line here. So I'll draw a horizontal line from here. Okay. So the next thing I'm going to do is that I'm going to calculate the circumference of this penetrating cylinder. Circumference of the penetrating cylinder. Circumference of cylinder is pi d. Circumference of cylinder is pi d. So it's equal to pi d. So and pi is 3.142. So 3.142 times 36. That is diameter of the penetrating cylinder times 36. So if I multiply 3.142 times 36. So that is 113. That's 113.1. So I can just approximate it as 113. So I will take 113. I'll measure 113 on this line. 113 on this line. 113 on this line. So this is 100. This is 110. So 113 is here. This is 113. So here I have 113. Okay. This is 113. So I'm going to divide this 113 into 12 equal parts. This is because I draw half. If I have drawn a circle here, I'm going to divide into 12. So I can call this one, I can call this this is 0 and this is 6. So I can call this okay, so let me come back to that. So so I'm going to divide this into 12 equal parts. So I will draw a line, an inclined line here, and then I will take my compass and I will make 12 arcs on this line. 12 arcs on this line. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, so I have 12 points there. Then I will join the last one at this point. Join the last one at this point. Okay. Okay, so the next thing I'm going to do is that I'm going to draw parallel lines. So I will set my set square along this line. Okay, so now we move it to the next point. So move it to the next division, draw a line. So move to the next division, draw a line. And then move it to the next division, draw a line. Move to the next one, draw a line. So move to the next one, draw a line. The next division, draw a line. So next point, draw a line. Next point, draw a line. Okay, so next point, I will draw a line. Next point, draw a line, and then next point, which is the last one. So I draw a line. Now, so one thing about this thing is that I'm going to number it. If you look at the numbering, it will go like this. We are opening from this 6. This is where we have the seam. So if I open from here, if I fold this, as I fold this paper like this, if this point here is 0.6, if this point is 0.6, so by the time I open it, I'm going to have 6 on this side, and then I will have 6 on this side. That's what we are going to do. So I'm going to have 6 at this point. Here is 6, and this end is also 6. Okay, by the time I open it, this zero will be in the middle. 0 will be in the middle. 0 will be in the middle. So that's what we are going to do. So to make it simple for ourselves, by open from here, the next one I'm going to have is what? Is 5. I will write 5 here. I would like to put 5 here again. 5, 5. So because we are going to have, since we have 6, 6 here, so we can have 5, 5 here. So the next is 4, 4. So this is 4. And I will also have 4 here. Next, I have 3, 3. So this is also 3. Then next I have 2, 2. So this is 2. And this is also 2. Next I have 1, 1. So this is 1. And this is 1. Then I have 0 in the middle here. So this point is 0.0. This is 0.1. And this is 0.1. Okay, so the next thing I'm going to do is that I'm going to draw vertical lines at each point. Vertical lines at each point here. Vertical lines at each point. Okay. Okay. So, all right. So the next thing that we are going to do, it's simple. So we are opening from 6. So put your compass at this point here on this line. On this line. So put your compass at 6. Extend to this point where line 6 touch the cylinder, the vertical cylinder. Just extend your compass to that point. Extend your compass to this point. So and put it at 6 here. Put it at 6 here. So you draw an arc here, and then you come to this point 6 here. Make an arc. So the next we have 5. So put your compass at this on this line and extend to where 5, where 0.5 on this curve. Okay, then put it at 5 on this pattern. Then bring it here. Okay, so next 4. So put it on the point, on point 4 on the curve of interpenetration. So bring it to 4 here. Bring it to point 4 and make an arc here. So bring it to 4 here. Make an arc here. Okay, then we have point 3. We have point 3. So this is point 3. So put it at 3 here. So make an arc here. And then bring it to point 3 here. Make an arc on this line 3. So next 2. Next is 2. So extend the compass to that point on the curve. So bring it to point 2 here. So make an arc here and bring it to point 2 here. Make an arc here. Okay, so next is 1. So this is point 1 here. So this is point 1. Okay, so bring it to point 1 here. So make an arc here and then bring it to 1 here. Make an arc. Then we have 0. So bring it to point 0 here. Okay, so put it at 0 here. All right, so this point will be joined together with our French curve. So let's bring out the point, this point here, this point here, this point here, here, so this point here. Okay, so I'll now take the French curve. So I take the French curve and bring out this shape. Bring out this shape. Okay, so it goes like this again. Just take it easy when you are making use of the French curve. You don't have to rush. So So that's the curve. So I need to make this thick. Alright, so this is the surface development. This shape is the surface development of this penetrating cylinder. So it's as simple as explained here. As simple as explained here. So you can learn more. Look for questions under this topic and solve them as I've done here. So this is a standard WAEC question. This is a standard WAEC question. So subscribe, like the channel, and share with friends. So when you subscribe, so whenever I upload a new video, you get a notification. So thank you.